Hi everyone. In this video, I will discuss the reliability and validity assessment process. Before we can run data analysis and test our model, it is important to make sure that the data is reliable and valid. The reason is that unreliable or invalid data will result in high variation, poor model fit, or incorrect model estimation. First, let's talk about reliability. Reliability is an assessment of the degree of consistency between multiple measurements of a variable. Internal consistency is a common method of measuring reliability. It represents the consistency among variables in a summated scale. Individual items of the scale should all be measuring the same construct and just be highly intercorrelated. Cronbach's alpha is one of the most popular methods for testing the internal consistencies of measurement instrument. A Cronbach's alpha of 0.7 or higher indicates good reliability. The textbook suggests a more conservative reliability coefficient, also called construct reliability, which is derived and calculated from the confirmatory factor analysis. This is a formula that can be used to calculate the construct reliability. As we can see in the formula, the construct reliability is evaluated based on the factor loadings and error variance. A construct reliability of 0.7 or higher suggests good reliability, indicating that internal consistency exists, which means all measures represent consistently the same latent construct. It is recommended that we use both Cronbach's alpha and construct reliability to measure the reliability of constructs. Cronbach's alpha can be calculated using SPSS, and construct reliability can be derived and calculated from the confirmatory factor analysis using AMOS, which will be covered in DAV 724. The next step is to evaluate the construct validity. Construct validity is the extent to which measured items actually reflect the theoretical construct that those items are designed to measure. Campbell and Fisker suggest that construct validity could be best evaluated through convergent validity and discriminant validity. These are two popular validity assessments that have been used in most research studies. Convergent validity refers to the extent to which measures of the same construct are correlated. In other words, it provides empirical evidence that items that are indicators of a specific construct should converge or share a high proportion of variance in common. Discriminant validity refers to the extent to which constructs are distinct. That means discriminant validity provides empirical evidence that a construct is unique and captures some phenomena that other constructs do not. There are several ways to evaluate convergent validity. The first method is to use factor loadings. High factor loadings on a factor indicate they converge on a common point, the latent construct. Standardized factor loadings should be used for the assessment purpose because they range from -1 to +1. Factor loadings can be extracted from the confirmatory factor analysis. The rule of thumb is that factor loadings of 0.7 or higher indicate good convergent validity. In addition, factor loadings of 0.5 or higher are considered acceptable. Another common method is using average variance extracted or AVE to evaluate the convergent validity of each construct. AVE is calculated as the mean variance extracted for the item loading on a construct. This is a formula for AVE using factor loadings derived from confirmatory factor analysis. You can see in this formula, first we need to square the factor loadings for all items, add them up, and divide by the total number of items. The rule of thumb is an AV of 0.5 or higher indicates adequate conversions. Again, it's recommended to use both factor loadings and AVE to evaluate the conversion validity. As for discriminant validity, there are several ways of testing the discriminant validity. The textbook by Head all explains these methods. But the most rigorous and popular method is to compare the square root of AV value for any construct with the correlation estimates between that construct and other constructs. If the square root of AV value is greater than the correlation estimates, we can conclude that we have sufficient evidence of discriminant validity. Again, we need to make sure that we have both convergent and discriminant validity before testing the model. And here is a list of important references that we should know regarding the reliability and validity assessment. Thank you and bye now.